Okay, this is Pre-calc, section 7.1, and we're talking about solving systems of equations. Most of what we do in this lesson is going to be review from Algebra 1 and Algebra 2. So, when we have two or more equations and two or more variables, we use a system of equations to find the solution. So, a solution would be an ordered pair that satisfies all the equations in the system. So, here's an example of a system. I'm going to slide this up, and the ordered pair 2, 1 is a solution because it works in both of the equations. I put it in this equation, put it in this equation, and they both check. So we say 2, 1 is a solution to the system because it works in both equations. Now let's take a look at the substitution method. If I have a system of equations and I have one of the variables solved, which means that I can say x equals y plus 3, meaning that x and y plus 3 stand for the same quantity, and so I could take one out and put the other one in. And that's exactly what we're going to do. We are going to put y plus 3 in for x in the top equation. So notice I take my top equation, I take out the x, and I put in what x equals, and then I get a simple linear equation that's easy to solve. When I do that, I get y equals 1. Now I need to back substitute to find the value of x. So you can see here, if I take the value of y equals 1 and stick it right in here in one of the original equations, I can use either one, but I need to put it in one of the original equations, and then I find my other value. In this case, it's x equals 4. So my solution is 4, 1, and let's take a look at what the graph of that looks like. Here's the check. I put it in both equations. I put it in the top and the bottom equation, and they both check, which means I do have a solution. And now let's look at the graph of that. You can see by the graph that the solution 4, 1 is the place where both of those lines intersect. Okay, here's another example. There's a system here, and I don't have it solved for y or for x, so I'm just going to take one of the equations. I think I'll take the top one, and I'm going to solve it for y. So y equals 2 minus 2x. What that means is I can put a 2 minus 2x every place I see a y, and I'm going to do it right here. So let's jump down here at the bottom, and you can see that I've taken out the y, and I've put in what y equals, which is 2 minus 2x. I did that in the bottom equation. When I solve that, I get x equals negative 1, and now I just need to back substitute to find y. So I'm going to take my value of negative 1, and I'm going to put it in for x in one of my top equations, and I'm going to find y equals 4. So I get my solution of negative 1 comma 4. If I look at the graph, you can see that the place where those two lines intersect is indeed the point negative 1 comma 4. So here are the steps for solving a system with substitution. You need to solve one of the equations for one of the variables. Then you're going to substitute what you found in step 1 into the other equation to end up with an equation with one variable. You're going to solve that, and then you're going to back substitute that value into one of the original two equations to find the value of the other variable, and then check them in both to make sure that you do have the right answer. Okay, we're going to take a look at another system here. This one has some x squareds and y squared, so it's not as simple as the one that we've worked through already. So what I've decided to do is take the second equation and solve it for x. So that means that x and 1 minus y are equivalent, and that means that up here where I see an x, I'm going to take it out and I'm going to put 1 minus y. So you can see here's my equation. I've got y squared and x squared. I'm going to take out this x and I'm going to put in 1 minus y. Now when I square this, since I'm squaring a binomial, I'm going to get this trinomial right here. And after I combine like terms, notice that this is a quadratic. Quadratics need to be solved either by factoring or the quadratic formula. So we get all the terms on one side, and notice that there's a common factor of 2 here, so you could either pull the 2 out or you could divide through by 2, but either way, when I factor this polynomial, I get y minus 2 and my y minus 1. So I end up getting 2 values for y, which is okay. It just means that I'm going to have to take each value for y and find the x that goes with it. So if you look at this, I needed to take y equals 2 and find the x that goes with that, and I take y equals negative 1 and find the x that goes with that. So I actually end up with 2 solutions. Now if you look at the graph of those 2 equations, you have a circle and a line, and they are going to intersect at this point and this point. So it makes sense graphically that we would get 2 solutions to that system. So here's one more system that combines a linear equation with a quadratic. And it's already set up nicely to do substitution. So I'm going to take an x plus 4 and put it in where I see a y. And that's going to happen right here. So here's my original equation. I'm going to make my substitution for y, and what I end up with is a quadratic equation. So let's slide this down, and look what happens. This one doesn't factor. I put it in the quadratic formula, and I get something here that has a complex answer because of that negative under the radical. That means this system has no real solutions. So let's take a look at what that means graphically. If you look at the graph, these 2 graphs do not intersect. And that's what it means if you end up with no real solution. It just means that your graphs, the graphs of your equations never will intersect. The last topic in section 7.1 is to solve systems using a graphing calculator. So I've got the steps outlined here, and you can read through those if you want. You can pause the video and read through them, but I'd really encourage you to watch a separate little video that I have posted on the ChatMath website for this week. It goes through an actual example and shows you which buttons to push and all of that. So I'd strongly encourage you to do that so that you see an example of exactly how to do find the solutions using your graphing calculator. Because there are some problems in your assignment that are similar to this application problem, I think it's worth walking through it so that you get an idea of what it's about. So a company has fixed monthly manufacturing costs of $12,000, and it costs 95 cents to produce each unit of a product. The company then sells each unit for $1.25. How many units must be sold before this company breaks even? Because the break-even point is where the cost equals the revenue. So let's say you're going to make X clocks or something, and it costs 95 cents to produce each one. Your total cost is going to be the cost per unit, which in this case is going to be 95 cents times however many you're going to make. So we don't know that, so we're calling that X. And then you're going to add your fixed cost. And in this case, that's $12,000. So your equation is going to be C equals 0.95x plus 12,000. Now when you're looking at the revenue is what you take when you multiply how much it's going to make for you. You're going to make $1.25 every time you sell one of these clocks. And then X represents the number of clocks. So your revenue equation is going to be R equals $1.25 times X. So our system of equations looks like this. I've got two equations, my cost equation and my revenue equation. And the break-even point happens when the amount for revenue equals the amount for cost. So what we're going to do is we're going to take this and we're going to change it to a C, because I want the cost to equal the same thing as the revenue. So what I get for both of those equations needs to be the same amount. So we can solve that one easily by substitution, because I'm going to take $1.25 times X and I'm going to replace C in the first equation with that amount. So that gives me this equation right here. And then if we solve that, I'll just scroll up so you can see how it solves. I end up with X equals 40,000. That means I will break even if I make 40,000 units, or or 40,000 clocks, or whatever it is. Now looking at this next question, it says how many units must be sold to make a profit? Because we don't want to just break even, we want to make a profit. So the way that you calculate profit is you need to take your revenue and you have to subtract your cost. So the revenue is the money that you receive from selling your product, and the cost is the money that you spend to produce the product. So for our problem, here's our cost equation, that's the same. Here's our revenue equation, that's the same. But what we need to do is to take the revenue minus the cost in order to find out what our profit is. So we need to take our profit equals revenue minus cost and put in our values for cost and revenue. So here's the revenue minus the cost, and it looks like our profit is going to be 0.3x minus 12,000. So if I want the profit to be 27,000, then I need to take that equation and I need to take out the P and put in 27,000. And if I solve this equation, which I get X equals 130,000, that means if I want to make a profit of $27,000, then I need to produce 130,000 units. So refer back to this example if you need to when you do your problem in your assignment.